DNA, deoxyribonucleic acid, is our unique genetic code, and it's revolutionized detective work. DNA profiling is now so advanced that it can help identify a criminal from a single flake of dandruff or a bead of sweat left at the scene of the crime. And that's using technology that wasn't even available until the mid-80s. In 1984, while studying genetically transmitted diseases, Professor Sir Alec Jeffreys noticed huge variations in the DNA sequences he'd gathered. He realized this meant the DNA we leave behind, wherever we go, is like a genetic calling card signaling our visit. The application to forensic detection was obvious, and the idea of DNA profiling was born. DNA profiling is now routine, and over the years, scientists have refined their techniques to make it even more sophisticated. The latest technique is called low copy number, or LCN, and has enabled a DNA profile to be taken from ever smaller samples. Going back 20 years to when it was first used, what sort of samples were you using to get your DNA?
Well, the first DNA tests were very insensitive, although they were very powerful. So we'd need a blood stain about the size of a 10-pence piece, which in forensic terms is a lot of material. Nowadays, if you could see a blood stain on my shirt, even using a microscope, there'd be more than sufficient for current day tests.
What difference has the advent of low copy number meant?
Well, the first DNA test simply tested the DNA that was present in the stain, and sometimes there just wasn't enough to give us a signal to detect. DNA has the ability within the body to copy itself into every single cell of our bodies. And what we do using the LCN low copy number technique is to hijack that ability and persuade DNA in a test tube with certain chemicals present to copy itself repeatedly. So we can make 2 copies, then 4, 8, 16, 32 and so on. So we have a chain reaction. So after 28 times, 28 cycles, we ended up with about 1 million times what we started with.
Presumably advances in technology in DNA profiling now mean that you can perhaps go back and review older cases where you didn't have enough sample to use the older techniques.
Well, several years ago, forensic scientists had nothing but blood grouping tests to investigate crime, and they were not very sensitive and they weren't very discriminating. Now, with the advent of DNA technology, it's possible to go back and reconsider those cases, which may have body fluid, which is sufficient for modern day tests, and provide highly discriminating information to the police to help them reinvestigate and maybe reopen that case.
One such case was that of Mary Gregson in 1977. Raped, murdered and thrown into the water, the case proved impossible to solve for over 20 years.
When Mary's body was removed from the river, it was taken down to the public mortuary at Bradford, and prior to post-mortem all her clothing was removed. When that was examined at the Forensic Science Laboratory at Wetherby, samples of semen were found on various parts of that clothing. When the semen was examined, we managed to get a blood group from it, but we didn't have DNA back in 1977. And the blood group was a very common blood group that belonged to round about 40 to 50% of the population. So really, its evidential worth back in 1977 was extremely limited. We interviewed between 9,000 and 10,000 people, so you can tell how big the inquiry was. But we didn't find the killer. In January of 1978, the inquiry was suspended, and I use the word suspended because it was a murder inquiry, and a murder inquiry is never closed. Every time there was a development with DNA technology, the sample was resubmitted to the laboratory. Eventually, a technique known as low copy number came out, and all that means is that you can get a DNA profile from a much smaller sample. And when that technology came out, Mary's sample was resubmitted, and we got, eventually, a full profile of a killer.
In September 2000, Ian Lowther was finally convicted of Mary's murder and jailed for life thanks to low copy number.